guys, what's up? It's your boy Trix. Today is another coding video where I'm going to be trying to learn Rust. Hopefully it's not like yesterday, but you never know, things happen. But yeah, let's get into the video. So, go into Rust. Let's do some exercises. So I'm going to do Gigasecond, Anagram, and space age. Okay, let's see what this is. Given a moment, determine the moment that would be after a gigasecond has passed. Gigasecond is 10 to the power 9 seconds. Okay. If you're unsure what operation you can perform on parameter, take a look at time crate. Okay, I'll have it open, which is listed as a dependency in the cargo.toml file for this exercise. So cargo.toml just has dependency as time. Okay, so in here, returns a date time 1 billion seconds after that start. Okay, so let's have a look. This is saying specifically a primitive date time. Yep. So a primitive date time has that, right? So primitive date time equals that, and then time, date time, whatever. Okay. Looks like it's gonna be a scuffed video again. Solutions, let's have a look. This one and this one. So this one. Date time. So it takes start and just adds IE 9 seconds. So if I do start plus 1E9 seconds, that. So what does that do? Does that work? I might need to import another library. 1E9 seconds. Yeah. So that's dependent on this library. I don't want to import another library because you shouldn't have to. This one, because this one makes sense. Primitive time as date time. Yep. Nope, don't use that one. Because if it's just going to use time anyway, I might as well just use this. So all this is saying is, from the same time library, you want to find ext, which is, I'm assuming, is just an extension, and then you're looking for numerical duration, right? And all you're saying is, in this function returns a date time 1 billion seconds after the start, right? So the function, the public function, is named after it takes a date time variable which is assigned to start and should return a date time when you've done your operation or whatever. Inside the function body, you take the start time and you add 1 to the power of 9 seconds, right? Because all this is saying is you're supposed to add a gigasecond, right? So if you look at a, what's it called again? Exponents? No, it's not called exponents. It's like, it's taught in physics when you're doing bases. Base 10. No. It's also taught in computer science when you're doing kilo, mega, giga. Here we are. Okay, so hopefully you guys can see this. No, hang on, let me change it to this one. And new file. There we are, that should be out of the way of my head now. Okay, so all this is showing is if you have kilo, it's 10 to the power 3, right? when it's in power of 10. And this is saying that this is 10 to the power of 9. So when you're actually executing this, it will be giga with 10 to the power of 9. That's all. So 1e9 is just 1 exponent 9. This might need to be 10 if I'm thinking of it correctly. Does that work, or do I need to do 1 to the power 9? 1 to the power 10, sorry. Okay, so I'm assuming all this is doing is the 1 stands for like 10 or something, and then exponent 9. So you're saying 10 to the power of 9. Whereas in like binary is represented as 2 to the power of whatever. So if you have 8 bits, it'll be 2 to the power 8 to account for all of the bits in that byte. So kilo would just be 2 to the power 10, mega 2 to the power 20, right? Whereas with base 10s, it'll be 10 to the power 3, 10 to the power 6. So 1,000, which is 1k, is 10 to the power 3, if that makes sense. Markers complete. Confirm. Show more. That's just me not knowing what the library is. Like, that's all. If I knew what the library is and like I actually understood the library, maybe I would understand that. Magazine cutout. And this one is poker, allergies, bowling.dsl, grade school, palindrome, queen attack, RNA transcription, and simple linked list. This one's poker, allergies, tournament, robot simulator, rectangles, and scale generator. So when I was doing the Go ones, literally the Go ones would just recommend you one to do right after. I'm assuming that the only difference is with Rust, it makes you, if you just follow the syllabus, you're going to get confused. So the best way to do it is just to follow the exercises and do the exercises accordingly. So the next exercise is this, and then you just keep going. And then once I like understand what the previous one is, I'll be able to do it. But with the Go one, it was very straightforward. I don't know. I feel like this might just be like unneeded criticism, but for the Rust one, if they want you to be able to do these, I feel like what they've done here, they should do that for the other ones as well. So if they know that you're gonna need, like in poker, for example, you need to be able to understand vector objects, right? But I only understood vector objects once I done which one? Which one taught vector objects again? I think it was short Fibonacci sequence. Yeah, this one taught vector objects. If they want people to like understand it properly and to follow this through the syllabus, I feel like they should also do what they've done for the enum basics and structs, but for all the other ones as well. Because if you want someone to be able to accomplish these with no prior knowledge in that language, they should do the other ones of these in a similar fashion. Because vec macro, yeah, cool, I learnt it doing a short Fibonacci sequence, but this one should probably be above enum basics if you're gonna have us do poker. And I'm assuming it'll be like that for other ones as well. Because if, like, say for example, tournament, if you look at the exercises, where's tournament? Bowling.dsl, ETL grade school, Hamming, ISBN, palindrome. Did I go past tournament? Tournament's all the way down here. If all of these easy ones and all of these medium ones are above it, I'm assuming that these should be completed first. So yeah, it's probably unneeded criticism, or it's probably like, oh, you're supposed to have previous experience in Rust to be able to do this. But coming from another language, I should be able to model my way through it. If things are very different, have those resources available in the instructions or the task or whatever, like you do with the other ones, and include these in the syllabus too. Don't just include like lots of them for two of them, include lots of them for the other ones too, so that you know, okay, cool, I need to complete these before I go on to the next one. I feel like that makes sense. if that's unneeded criticism, or you feel like that's not like a valid excuse, I completely understand. That just might be me. Like, that's just how I feel like it should be. I understand that people have a different view towards what I think for that, but I feel like that would be a lot better coming from like someone trying to learn it. I don't know. An anagram is a rearrangement of letters to form a new word. Given a word and a list of candidates, select the sublist of anagrams and the given word. Given listen and the listen candidate like enlist, Google, inlets, and banana, the program should return a list containing inlets. So basically, all it's doing is it will take a word and then it will look through the possible anagrams, and if it finds each letter in this inside of the possible anagram and it matches up with the same length and everything and the same number of characters per whatever, then it should return the actual letter, the actual anagram, right? The solution is case insensitive, which means the word WO in caps and RD in lowercase is the same as word or word. It may help to take a peek at the STD library. Thank you. See, like stuff like this. This is really helpful because I can read through the documentation. The solution cannot contain the input word. A word is always an anagram of itself, which means it is not an interesting result. Given hello and the list hello or ole, the answer is ole, yeah? Oh, so say for example you have a normal word. If the possible anagrams also contain that word, do not return the same word, just return the anagram of that word. Okay. You are going to have to adjust the okay, so inside there. Function signature provided in the stub in order for the lifetimes to work out properly. This is intentional. This is intentional. What is there demonstrates the basics of lifetime syntax, and what's missing teaches how to interpret lifetime related compiler errors. Try to limit case changes. Case changes are expensive in terms of time, so it's faster to minimize them. If sorting, consider sort unstable, which is typically faster than stable sorting. When applicable, unstable sorting is preferred because it is generally faster than stable sorting and it doesn't allocate auxiliary memory. Okay, I don't know why I said auxiliary instead of orcs. Solutions, let's have a look. Okay, let's have a look at this. Lowercase, word, possible anagrams, hash set. Okay, this is using a hash set, okay. Lowercase 2 lowercase c character, so that gets absolute value. I'm assuming if not c dot is lowercase, then convert it to a lowercase and then to a string, else just convert everything to a string if the actual character in that string is already a lowercase. The LW vec word, okay, hang on, I want to see how others do it as well. That's collect anagrams, p anagram. So that's a third iteration. This is the first iteration. This one is the first iteration, and the second looks somewhat similar. 7 months ago. This guy would dog it all in one. God damn. Okay, let me look at this and then try to muddle my way through. If I understand the majority of it, I'm going to submit it. If I can't understand it at all, I'm not going to submit at all. I want that to just be for me, because there's no point in me doing one and submitting it if I don't at least completely understand it. If it's just one line that I don't really understand, I'll accept that. But if it's like multiple lines, then no, I'm not going to do it. So, as I was saying, let 2 lowercase s equals c char. So this is just getting the absolute value for c. If that character is not a lowercase, then convert it to a lowercase and then to string. Otherwise, just convert the whole thing to a string. Let LW equal, it's a vector object with no type. So it takes the word, converts it to a character array, then maps the 2 lowercase string for each character in that in the string, whatever, into a map, and then collects it all as a vector object. Then you have a mutable object called SC, which is a vector object that has no type, which takes the word, turns it into a character string array, then maps the lowercase string variable to it, and then collects it all again to store in that vector object. Then you do an unstable sort on this sorted character array, I believe. Then you have a result object which iterates through each of the possible anagrams, right? And then on that object you do a filter stream which conducts everything inside of this anonymous function. So you take W, which is just a value inside of that result. So if it's a filter and you're iterating through the possible anagrams in each string in the possible anagrams, W is just each word in the possible anagrams, right? So you have SCI, which is a mutable object, which is a vector without a type, which takes the word in the possible anagram, and each word in the possible anagram, converts to a character array, maps lowercase letters, the lowercase string, to that array, and then collects it all as the vector object. Then there's a variable for same word, which is a Boolean object to check if the lowercase word and the word inside the possible anagram are the same, I believe. Hang on, let me read that. Lowercase word, yeah. So that's the word you have. Then it has sorry for that. SCI, what does SCI do? Where's SCI? SCI is W, so the actual word that's passed into the possible anagram, so one of the words in the possible anagram, as an array as a vector object with the two lowercase string mapped to it. Yeah. And then collected together to make the vector object. Okay, this is just a Boolean, right? To check if they're the same word. So like, this is for this scenario, where if you have hello, you don't want to return hello in the possible anagrams. You want to return the word that isn't the same as the word that's passed through it. So SCI.sort unstable. So this is just a normal sort on another sort, because you sorted on this for the sorted characters, and I'm assuming this is sorting the words inside this object for each word in the possible anagram, right? And then if SCI is equal to the sorted word, right? I keep saying word. So if the possible anagram, when it's sorted, is equal to the word that is passed to the function when it's sorted, and they are not the same word when they're not sorted, then map that word as W. This line I'm not sure, but all this line does is just return a hash set where you have your iteration, and because I'm stupid, sorry. Okay, basically this map says get the address for the word, because when you have a string, it in memory, it stores each letter in a separate memory location, but they're all addressed they all are addressed at the same pointer. So if you point to that location for a string variable, it will point to that whole word or that whole string. So what this is saying is get the whole string and then return W, where W is stored as a result. So for the possible anagram, it is stored as a result, and all you're saying is on this line, you're returning a hash set where from iter result. So this from iter, I'm not sure, but all you're saying is return a hash set with the result. I want to see what from iter does though. First, set from iter. From iter. Okay, control F from underscore iter. Create a value from an iterator. TS. So into iterator and then item T. Hash set TS. Okay. From the. Okay, so I'm assuming. Okay, so this is basically saying because you're iterating over possible anagrams inside a result, you want to, and this is an iterator itself. The result is an iterator. All you're saying is from hasset return the iterator that is in result. So all you want is this to iterate and then retrieve the possible anagram that matches the lowercase word that is passed to this function. What's wrong? Mm-hmm. Do I need to copy the whole thing? I wonder what's different. Yeah. Anagrams for. Okay, I'm just going to chuck this to the side so I can see what's different. Pub fun for a word and sure possible anagrams and oh. A sure apprentice. There we go. I don't know what this apostrophe A means. Because only used in this line. Does it say? No, it doesn't. Confirm, syllabus. Once I finish ng API, this one, and this one, then I know I'm done. With Go, it's actually really easy to finish this. Like a couple of them I did cheat. Not gonna lie, I did cheat on a couple of them. But most of them it was like very straightforward. It was just like writing in Java honestly or Python when you were doing it in Go. Like, do you see what I'm saying? I don't know why the ones in Rust are a lot harder. But anywho, in Go I completed 29. In here I've done 14. So let's see how I get along, shall we? Yeah. Wait, how many have I completed so far? I think I've completed 2. Yeah, I completed 2. So let's do the next one. Space Age. Starting editor. Actually, are they even easy ones? Because I might as well just complete all the easy ones first. Armstrong numbers. Starting editor. An Armstrong number is a number that is a sum of its own digits, each raised to the number power of the number of the digits. For example, 9 is an Armstrong number because 9 to the power of 1 is 9. 10 is not an Armstrong number because 10 is not equal to 1 to the power 2 and 0 to the power 2. That's easy. That's easy. Anybody who watches this and is like, "Oh, you said it was easy," I'm genuinely concerned that someone thinks that is easy to complete. Okay, let me see. Okay, you know what? It's already a scuffed video. Might as well. Solutions. This one. Get this. Okay. So let's have a look. So pub structure duration given an age that can calculate how old someone would be. Okay. So fm from as self. Okay, so fm from as self duration. Instead of me doing that, couldn't I just do self? Okay, hang on. Let me grab this. Because you're returning a self, right? So all I really need to do is instead of duration, just yourself. And then just chuck this and that. And then run tests. Doesn't that work? Boom. Oh, wait, hang on. Colon, from. That's an F64. I'm looking for a U64. No. This one. Okay, so that's an F64. Just passing an F64. Thing. Self duration as F64. Okay. Okay. Duration as F64. So all this is saying is, in the struct, you want this struct duration to have a float that's of 64 bits. Inside here, you just want duration because you're passing self. You want to return self. Self is just duration, right? So this is the same as just putting this inside squiggly brackets for duration, having what's it called, F64 comma and then a new lines for from, I'm assuming. All this is implementing is a function from U64 for duration, where in this function you have the from function, which takes a start time or something that's a U64, so unsigned 64-bit integer, I'm assuming, and you want to return self. Self is just your duration because it's for the major type. Then all you're saying is return a new object of duration with s as in float 64. Then you have pub trait planet. What is oi oi oi? Okay, constant orbital period. Okay. Okay, so let's have a look. Constant orbital period F64. Okay. Okay, so that's a variable for the planet class, I'm assuming. Well, it's a trait, but it's still a class. I'm assuming it's a class. Okay, now all you're saying is in here, you want to return a float 64, where D is a duration. Durations are floats. Durations aren't floats, actually. Hang on. Duration is the object, and .0 index retrieves the first index in that object, because you haven't specified the variable name for this value, so it just takes the first index. Divided by 3155760. 3157600. I don't know where this number comes from. Divided by self orbital period. That's just saying from this function get orbital period. So just divide it by this. That's fine. Then pub struct whatever, and then implements const orbital period. So now I understand why he done that. Okay, let me just grab all of these. So inside here, you have an orbital period, right? Which is basically saying, this is like old physics knowledge just coming back into my brain for some reason. Okay, orbital period is how long it takes for a rotation around the world for it to take, for that time period to equal 1 year, right? So Earth should just be 1, right? And these are all relative to Earth's time period. So that's why Mercury has a shorter time period than Earth, while Neptune has like a massive time period compared to Earth. You just grab these numbers from here, and that's their orbital period. That's fine. So all you're saying is in planet, you have constant orbital period, which you're assigned to each planet, right? And then in your year's duration, all you're saying is take the duration object that's passed to this function, and then get the first index from that duration, and divide it by 3 by this number. Then, once you have that result, divide it by the orbital period of that planet. This number, I don't know where it comes from though. 3, 1. Oh, that's the number of seconds. Does this want it back in seconds? Age in seconds. I didn't read it. Okay, yeah. Given an age in seconds. So you want so you get your duration, which is some person's age, in seconds, right? All you're doing is you're getting their age in seconds as an object. You want to get the actual age, which is the first element in that object, which is why you specify .0 on that object, right? To get the actual first element in that object. Then you're dividing it by the number of seconds in a year, which you can just calculate, or you get given the number here. That's fine. You're doing it as a float because the first element in the duration of object for someone's age in seconds is a float. And then you divide that whole calculation by the orbital period of a specific planet so that you can get their age in years. Mad. One, two, three. That's wicked smart. I would have never thought of that, but that makes a lot of sense when you, I don't know why, when I read, because there isn't like a lot of guidance on this, when I read it back, like read over the code, it makes so much more sense when you're trying to explain what someone else has written. I don't know why my brain thinks that that's easier than just like trying to figure it out myself, but somehow it does think it's easier. Anyway, thanks for watching. If you have any advice on how I can learn Rust better, or what you think I should do to learn Rust better, please leave a comment down below. I recently started a blog documenting like the stuff that I basically talk about, because I know some people like don't want to watch a 30 however long minute video of me trying to muddle my way through trying to learn Rust. So like I started writing a blog just so that people can read what I'm doing instead of like watching the video. I do link to the video in that blog though. I link to the blog on the about section on my YouTube channel. I'm not going to link it in the description. I just want to link stuff that I can update like on the fly in the description. I don't want to link stuff that's like static in the description, so I'm not going to do that. But yeah, if you like the video, please leave a like on the video. If you dislike the video, please dislike the video and comment down below how you want me to improve, or you would like me to change to make your viewing experience better, or what you would like me to improve generally. And please subscribe to the channel. Thank you for watching. I hope you have a great day. Peace.